Let's learn in this video why and how to use node pools in a Kubernetes cluster. So we'll see what are node pools, what is the difference between system and user node pools, how to use or how to schedule application pods on a specific node pool using labels and node selectors. Then we'll see how to allow only some specific applications to be allowed to be scheduled on a specific node pool using taints and tolerations in Kubernetes. Then we'll see how node pools could be used to reduce the risk behind upgrading the cluster, and then we'll see how to set up auto-scalability for each node pool. So typically within a Kubernetes cluster, the containers are deployed as pods into virtual machines called worker or agent nodes. These nodes are identical as they use the same virtual machine size or SKU. This was just fine until we realized we might need nodes with different SKU for the following reasons. Number one reason is that we prefer to deploy Kubernetes system pods like the core DNS, metric server, gatekeeper add-ons, and application pods onto different dedicated nodes. We want to separate system pods and application pods. This is to prevent misconfigured or rogue application pods to be accidentally killing system pods. The number two reason is that some pods requires either CPU or memory intensive and optimized virtual machines. Number three reason is that some pods are processing machine learning AI algorithms and needs GPU enabled virtual machines. These GPU enabled VMs should be only used by certain pods as they are expensive. Number four reason is that some pods or jobs want to leverage spot or preemptible virtual machines to reduce the cost of running these workloads. Number five is that some pods running legacy Windows applications requires sometimes Windows containers available only within Windows virtual machines. And these agent nodes, they should be either Linux or Windows agent node, or let's say within the same node pool. I cannot mix between Linux and Windows VMs. Some teams want to physically isolate their non-production environments like dev, test, QA, staging within the same cluster. This is because it's relatively easier to manage less clusters. So they won't have one single cluster for multiple non-production clusters. This is the number six reason for using multiple node pools. So these teams realized that logical isolation with using namespaces is not really enough. They wanted to use that physical isolation between the different environments or the different applications or different teams. So these reasons led to the creation of heterogeneous nodes within the cluster. To make it easier to manage these nodes, Kubernetes introduced the node pool. So the node pool then is a group of nodes that shares the same configuration in terms of GPU, memory, networking, OS, maximum number of pods, and by default, one single system node pool is created within the cluster. We'll see what is a system node pool later. However, we can add node pools during or after the cluster creation. So we can end up with multiple node pools within the same Kubernetes cluster. We can also remove these node pools at any time. So there is two types of node pools. First one is the system node pool. It's used to preferably deploy system pods. Kubernetes could have multiple system pods. At least one node pool is required with at least one single node. System node pool must run only on Linux due to the dependency to Linux components. There is no support for Windows right here. So when you create a Kubernetes cluster, by default, it will have one single node pool that is of type system node pool. And within that node pool, we should have at least one virtual machine available there. And within AKS, that VM should have at least 4 GB of memory available. The second type of node pools is the user node pools. It's used to preferably deploy application pods. Kubernetes could have multiple user node pools or it could have none of them. All user node pools could scale down to 0 nodes. A user node pool could run on Linux or Windows nodes. As I said before, we can create a node pool that could use Linux VMs or another node pool that could use Windows VMs. Node pool might have some small different configurations with different cloud providers. In this video here, we'll be focusing with node pools within the AKS cluster in Azure. So let's see how that works with AKS, with Azure Kubernetes Service. So let's first start by creating a new AKS cluster. So you can do this either from the Azure portal or using the command line. From the Azure dashboard right here, I started creating a new Kubernetes cluster, and from here I specify the name of the resource group, the name of my cluster, the region, the availability zones I want to use for my different nodes, and the version of the Kubernetes cluster available per today, and also the node size for those VMs. So this will create a node pool with 3 VMs that uses the D2S V4 that have 8 GB of memory and 2 virtual CPU. Note that here next we have a full configuration for the node pools. So here we have that default system node pool that uses the OS Linux, and we can also add another node pool right here. So we don't want to do that right now, but we'll do it later. For now, let's just create this cluster. So I'll go next to authentication, where here make sure that I've selected airbag and system assigned managed identity just for the demo. And then on the networking section here, I want to choose the Azure CNI, and then I'll go to pick here Calico as networking policy. You can ignore these preferences actually, but it's just for the demo because we'll need some system pods right here. Next, if I go to integrations, nothing to change here except Azure policy because I want to add more system pods that here because I need it in the demo. Then next, if I move to the tags, nothing to change, review and create, and here we'll trigger the creation of that cluster. Now once my cluster is created, I can go to the node pools, and from here I can see that I have that agent node pool that is of type system, and that's running my 3 virtual machines. And if I go here to nodes, I'll be able to see these 3 VMs running inside that agent VM. If I choose one of these VMs, then we'll see that here they are not using any taints, but they are defining some labels right here, like the name of the agent pool, which is agent pool in this case, and some other labels that we'll be using later in this demo to decide which pod could be scheduled into those node pool. These are of course the same labels that you can see within the YAML that describes that node within your cluster. So what we want to do now is that we want to keep the system node pool for the system pods running in our cluster, and we want to create another node pool to run our application pods. So let's go to create another node pool. So using the Azure portal, I go to add a new node pool. I'll call it here apps node pool, and I'll make sure here that it uses the type user node pool, not the system. And then for the OS, I want it to be Linux node pool, and then I'll go to choose the right latest Kubernetes version, and then I'll go to choose the number of availability zones that will serve this agent pool. And after that, I'll go to choose a size for my VM. And from here, we can use different sizes for these VMs. So if I'm using GPU, or if I need GPU for my pods, I can choose a VM that have GPU, or if I need CPU extensive VMs then I can choose that one. So here for my example, I just continue with the B VMs. I'll choose the B2MS, select that VM. And then we have here the option to set up the auto scalability. So I'll just disable it right now, but note it's recommended actually to do that. And I'll keep here the number of VMs to be, let's say, 5 VMs, for example. And then next I have some other optional settings like the max pods per node. So here by default it will be 30, but you can set it up to 250. Then we have here some other configurations like to enabling public IP per node if you have the use case to use that, and then the maximum surge definition that will define when you upgrade your node pool how many VMs will be upgraded at the time. So I'll keep the default one right here, and then here we have other options for setting up the labels and the taints. We'll see how to use these in a later demo, but for now let's go next to the tags, no need for this. So then I'll go to create this new node pool. So there are actually more options you get when you create a new node pool that are not available yet within the Azure portal, but you can unlock these options using the command line, which are to specify that you want to use spot instances for your node pool, and that's an interesting option to reduce the cost of running workloads inside your cluster. And the second option is that you can use a dedicated subnet for your node pool. I have here a sample command that shows you how that works within the command line, where you can specify your cluster name, the name of the node pool, the number of VMs inside that node pool, the type of or the size of that VM, the Kubernetes version on that node pool, the max pods per VM, and the priority, where here you can say regular for regular VMs or spot if you want to use spot instances, and then the number of availability zones, and then the mode, where you want to say here I want to use the user node pool, and then there is another config where you can say I want to dedicate this node pool to some specific subnet. Once the node pool is created, we can view it here from the node pool section, where we can see our 5 nodes are running successfully and they are using the user node pool with the standard B2MS VM size. And if I go here to nodes, I'll be able to see those 5 VMs running fine right here. I can also view these resources through the command line. So here I'm already connected to my cluster through AKS get credentials, and then here using the command iz AKS node pool list, I can view these 2 node pools. And yeah, here are our 2 node pools right here. By default, if we deploy a pod into the cluster, it could be deployed into any of the 2 node pools right here, the system or the user node pool. However, we can choose to target a specific node pool using labels on node pools and using node selector from the deployment or from the pod YAML manifest files. Each node pool has its own set of labels like the agent pool name. We can use the label to target the node by using node selector from the deployment file. Let's show the labels of one of the user node pool nodes with the following command. So let's see it first from the Azure portal. So if I choose here my user node pool apps node pool right here, for example, here tells me there is no taints and labels, but this is related to the node pool itself. But if I go to nodes and choose one of the nodes available here, then here I see right there is no taints onto this node, but there are a few labels that are defined right here, as we have seen in the first video. So we have a label called agent pool apps node pool. So this is the name of my node pool, and we have also lots of other labels that could be useful, like the SKU of the VM, the OS, which is Linux in this case, the zone for or the region in which my cluster is deployed in, and then the availability zone for that virtual machine, and lots of other useful information available as labels onto the node. We will use here the first label, agent pool, which is the name of the agent pool right here, which will be inherited by all the VMs inside that agent pool or inside the node pool, and we'll use that label to target deployment of my pods into that specific node pool. I can get the same information using the command kubectl get node with this name of one of my nodes right here, then -o.json, and then gq, and show just the labels from that node, and here I get the same labels that I get from the Azure portal. So here I have the agent pool apps node pool. So let's consider here this deployment YAML file that will go to deploy sample nginx container, 100 instances of that container, and then here this deployment will be using the node selector in order to specify where to deploy this pod, to which VMs, what are the characteristics of the VMs that should host this pod. So here we are specifying the node selector, and we are specifying the name of the agent pool, the label agent pool with its name. That's going to be the apps node pool. That's our user node pool. And this is what's going to tell Kubernetes to deploy those 100 pods only to the user node pool. So even if there is not enough space in that agent pool, it will not be deployed to the other primary system node pool. Let's now go to deploy that simple YAML file, kubectl apply -f app deploy.yaml. And then we can view where these pods are deployed, to which VMs or to which nodes using the -o node. And here we can clearly see that those were deployed to the apps node pool, our user node pool. So all of them, they were deployed to that node pool. No one were deployed to the other system node pool. So this means that here our application pods were deployed to a specific node pool. Now let's change gears and let's come back to that system node pool. So at first we said that we want to deploy system pods into the system node pool, but for now, actually that system node pool could accept any application pods. It could be deployed there, but we want to enforce that system node pool will accept only the system pods. Okay, I don't want to deploy my applications there. I want just to deploy, let's say, the system node pools like the core DNS or maybe Calico or the monitoring and the logging stack, the networking policy, whatever plugin I'm using, but not my application pods. So for now, we cannot restrict that deployment because the default system node pool that was created by default, it doesn't contain any taint. And the taints here are what we'll be using in order to deny deployment of non-system pods onto that node pool. However, we cannot, so into a node pool we can add labels. We can add labels to the different nodes, but we cannot add taints to an existing node pool. We can add taints only during the creation of a new node pool. So in our case here, we should go to create a new system node pool and give it the right taints that we want to use, and then we go to delete the old system node pool. So now to define what are the taints that we want to use, let's just show some of the taints used by the system node pools. So if we take here, if I go to workloads and then go to core DNS deployment, then YAML, and then by searching for tolerations, I should be able to see here a list of some of the tolerations used by these system node pools. One of them that is used commonly is the critical add-ons only. So this toleration will means that this is actually, let's say, a system pod that should be deployed into the system node pool. So now within our new system node pool, we'll be using this taint into the node pool so that our system node pools will recognize that that taint and they will be allowed to be deployed into that node pool. So now from the node pools, I go to add a new system node pool. I'll give it a name. I'll call it system pool, for example. That should be of type system, of course, and it uses only Linux. And I specify the latest Kubernetes version per today. Then we specify here the availability zones. We want to use 3 of them, and then we can specify another node size. I choose here the D2S v4. And then for the scalability, I'll keep it manual for now, and I'll be happy with the 3 nodes for that. Then we have a next configuration here that will specify the max pods per node, and then the max surge definition, keep it by default, and we have the important section is below right here in the taints. So here I specified a new taint, call it critical add-ons only, that was already predefined into my system pods. I set its value to true, and then for the effect here, this actually now should take the effect of no schedule. I don't want to schedule any pod if it doesn't have that toleration defined. Next, go for tags, keep it by default, then next, review. Now once that node pool is created, here I can go to that system pool, and I can clearly see the taints that were created with critical add-ons only. So for now, the system pods will still running on the old system node pool. They will not be migrated automatically to the new one unless we do one of the two operations. Either we go to drain the old node pool, or we can go to just delete the old node pool. Let's choose the easiest option. Let's go to delete the old node pool. So I'll go to select my agent pool that were created by default, and then I'll go to select delete. Confirm. And now if I go to try to get the pods running inside this cube system namespace and showing the nodes running these pods, from here I can see most of these pods actually are running inside the system pool. It's right, we can still see some pods, some system pods running inside the other user node pool, but those are actually either daemon sets, so they should be deployed into all the nodes into our cluster. But for the system node pools, those are deployed only into the system pool. So that's the case here for the metrics server and core DNS. Great, so what we have achieved now is that we have now two different node pools, one for the system node pools, and it's of type system, and we have a second different or physically isolated node pool that will run only my application pods. And note that here it's actually possible to force pods to be scheduled into the system node pool by adding the following toleration to the pod or the deployment. So this should be done to the components like Calico, Prometheus, Elasticsearch. So until here we have seen how to use node pools to separate the system pods from the application pods. But there are also another very interesting use case for using node pools, and that is to upgrade the cluster with less risk. So upgrading the entire cluster, I mean here the control plane plus all the node pools, might be a risky operation. So node pools here could be leveraged to reduce this risk. Instead of upgrading the node pool, we'll proceed with what we call blue-green upgrade. So this will be done into 5 different steps. First step is to upgrade the control plane only to the newest version. And this could be only done through the command line, at least until today. And that's the command AZAKS upgrade, and then you add the flag -- control plane only. The second step here is to go to create a new node pool with the newer Kubernetes version. If you are today using 1.18, for example, you want to upgrade to 1.19, then you will go to create a new node pool with the version 1.19. The step number 3 is that you will go to deploy your application pods into the newer node pool. Then you will verify that the application works fine on the new node pool, and if all is fine, then at the end, step number 5 is that you will go to delete the old node pool. So that will give you flexibility to also change some of the configurations into the node pool, especially the configurations that could be changed only during the node pool creation, like you attach your node pool to a subnet, or you choose the spot instance, or you change the max pods per node, or also specifying the taints for that node pool. So to conclude now, using node pools, we can physically isolate system and user application pods. It could be also used to isolate different applications, teams, and environments. It helps also to upgrade the cluster with less risk. In addition to that, it helps to use a new subnet with different IP range if needed. And it also helps to reset the max pods per node, which might be forgotten during the cluster creation. I hope this video was helpful for you. If you are looking for the scripts and all the commands that we have used into this demo, please check this GitHub repo, where you will find also a link for a new article that will be available on here. And if you are looking for more videos about DevOps, about Kubernetes, AKS, and Terraform, please go to check out my YouTube channel, where I post regularly lots of these videos.